Hello everyone. It's a continuation of our probability topic. We are into our first question in probability, which is read as when three coins are tossed simultaneously, what is the probability of getting two heads? What is the probability of getting at least one head? So let's proceed with the solution. So to find probability, since this is of three coins tossing experiment, I will first write down the sample space for three coins tossing experiment. How do we write that? First, we will write the two coin tossing experiment. What will be the sample space? Like H, 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 T, T, H, T, T. Then we will repeat this in the next row also. Then in the first row, we will end up everything with H. And the second row, everything with a tail. So by this, we won't miss any of the outcomes. So we wrote all possible outcomes. So one thing is clear, since there are 8 outcomes, the denominator of both the probabilities will be 8 only. Now, for the first question, the probability of getting two heads. Let's see. It says two heads. That means I can't consider anything less than two heads. Anything greater than two heads also I cannot consider. So what are the remaining? So here it is two heads. This one is two heads. This one is two heads. That means we have three favorable outcomes that will come in the numerator, and denominator will be all possible outcomes, which is 8. So that's the solution for the first one. Second question says probability of getting at least one head. Probability of at least one head. It means minimum one head. So I'll say probability of greater than or equal to one head. So let's check all those which are one head or more than one head. So everything has got heads in it except one. That means the probability will be 7 by 8. Let's move on to the next question. What is the probability of getting a sum of 9 when two dice are thrown? So here we will not write the entire sample space, because if I start writing sample space, I need to write 36 outcomes. So we know the number of all possible outcomes. Number of all possible outcomes for this experiment will be 6 square, because 2 dice, and it will be 36. That means the denominator of the required probability will be 36. Now, let us identify what are the favorable outcomes. Number of favorable outcomes. To find out this, first of all, we need to write what are the favorable outcomes. Favorable outcomes. Let's identify the favorable outcomes. So the sum should be 9. So let us start with 6. If I have 6, then the other dice should give me 3. If I start with 5 in the first die, then the other die should give me 4, because the sum should be 9. Then if I start with 4, then the other one should give me 5. If I start with 3, then the other should give me 6. I can't write 2, because if I write 2, then the other will be 7. That is not possible. So I have to end it. That means the number of favorable outcomes is 4 only. So the required probability, so that is probability of sum equal to 9 will be 4 by 36, which is 1 by 9. I can write. Let's move on to the next question. This is also two dice experiment, two dice throwing experiment. But the question, the favorable outcome is little different. It is talking about getting at least a sum of 9. We had already seen the number of all possible outcomes. All possible outcomes is 6 square, and that is equal to 36. Now let us identify what are the favorable outcomes, FOs, favorable outcomes. First, let us write down at least a sum of 9, means minimum. This means minimum sum should be, minimum sum is 9, means that means it can be 9 or 10 or 11 or 12. 12 is the maximum because this is involving only two dice. Right. First, let us write down all possible outcomes that can give me a sum of 9. Starting with 6, then it is 3. If I write 5, then it is 4. If it is 4, then it is 5. If it is 3, then it is 6. So all these outcomes will give me a sum of 9. Now let us write down for 10. So if I start with 6, then it is 4. Then if I start with 5, it is 5. If I start with 4, it is 6. I can't write beyond that because it will give me a number, and the sum will give me a number which will not be possible for a die. So next one, for sum of 11, 6 and 5, 5 and 6. For a sum of 12, only one possible outcome, which is 6, 6. So how many favorable outcomes? Number of favorable outcomes will be, first row is giving me 4 outcomes, 4 plus 3, 7, 7 plus 2, 9, 9 plus 1, 10. So that means this is 10, and the desired probability will be 10 divided by 36. So 2 5s are 2 18s are. So 5 by 18 is our probability. Let's move on to the next question. A number is selected at random from the numbers 1, 2, 3 and so on up to 30. What is the probability that it is divisible by either 3 or 7? That is first question. And second question is, it is divisible by 5 or 30. So one thing is clear, number of all possible outcomes, number of all possible outcomes. Since there are 30 numbers and you are drawing only one number, number of possible outcomes will be 30. Right. Now let us come to the first one. We need to find out what is the probability that the number is divisible by 3 or divisible by 3 or divisible by 7. So if I consider this as event A, this I consider as event B, it is like P of A or B or P of A union B, that we know it is probability of A. Probability of A means probability of number divisible by 3 plus probability of number divisible by 7 minus probability of number divisible by 3 and 7, means intersection basically. So I will do like this. Now, how do we identify the probability of number divisible by 7? One thing is clear, the denominator will have 30 because all possible outcomes. Numerator will be integer value. When I put a box bracket, we call it as integer value. Integer value of how many numbers are there? 30 numbers, 1 to 30, divided by this 3. Plus, here also it is 30, but here 30 should be divisible by 7. So I'll write divided by 7 minus here also 30, but here integer value of 30 divided by LCM of 3 and 7, because it should be both. LCM of 3 and 7 will be 21, right? So now this number 30 divided by 3 will become 10. So 10 by 30 plus integer value. 7 fours are 28, and subsequently there will be decimal number. We can ignore that. That means this is 4 by 30. Here LCM of 3 and 7 is 21. So 30 by 21. 30 by 21 will be 1 point something. So we'll consider only 1 divided by 30. So this will give me a result of 13 by 30. So this is the first part of the question. Same way, let us do for the second part. Probability of number divisible by 5 or divisible by 13. So that should be probability of number divisible by 5 plus probability of number divisible by number of numbers divisible by 13 minus probability of number of numbers divisible by 5 and 13. So that will be like denominator is 30 again. Numerator will be integer value of 30 by 5 plus denominator will be 30. Integer value of 30 by 13 minus 30 again. Integer value of 30 divided by LCM of 5 and 13. LCM of 5 and 13 will be 65. So directly 6 by 30, this one, I'm sorry. 6 by 30 plus 30 by 13, it will be 2 point something. So I will consider only integer value. So 2 by 30 minus 30 by 65, it will give you 0 point something. You'll have to consider only the integer value. So it is 0 by 30. So ultimately it becomes 8 by 30. And that will, if I divide both numerator and denominator by 2, it will be 4 by 2 4s or 2 15s. So 4 by 15 will be the answer. Let's move on to the next one. The board of directors of a company wants to form a quality management committee to monitor quality of their system. The company has 5 scientists, 4 engineers, and 6 accountants. Find the probability that the committee will contain 2 scientists, 1 engineer, and 2 accountants. So we will directly do the required probability. Let's calculate the required probability based on the above information, whatever is given in the question. First is, I will let us decide about that all possible outcomes. Totally, how many scientists are there? 5 scientists. Then 4 engineers are there. Then 6 accountants are there. That means totally there are 15 people available. Out of which you need to choose how many? You are supposed to choose 2 scientists, 1 engineer, and 2 accountants. That means you are supposed to choose only 5 people out of this. So 15 people, I have to choose 5 people. That means I will use the combination. So it becomes 15C5. This came from the total people, 5 plus 4 plus 6, which is 15. And how many I need to choose? 2 plus 1 plus 2, which is 5. So 15C5 will be our all possible outcomes. Now, how many scientists you can choose? You can choose only 2 scientists out of what? Out of 5 scientists. That means here it will be 5. I need to choose 2 out of them. And because you need to choose further also, 1 engineer needs to be chosen from 4 engineers. Since it is and, I will multiply 4C1, and then I need to choose 2 accountants from 6 accountants. So and 6 choose 2. Now we can evaluate this. So 5C2 will be 5 into 4 by 2. 4C1 will be 4. 6C2 will be 6 into 5 by 2. Whole thing divided by 15C5. 15C5 means it is 15 into 14 into 13 into 12 into 11. Then divided by, I will expand 5 factorial, 5 into 4 into 3 into 2 into 1. Now this 2 and this 2, which is 4, this 4 can be cancelled with this 4. And here 5 3s are 15, cancel this. And here this 2 into 1, I will cancel this 14 to get 7. So if I evaluate this, I will get finally 200 by 1001. So in this video, we will end up with this 5th question. Hope you understood all the questions, and it is quite easy. And in case if you like the contents of this video, I request you to like, share, and subscribe to my channel so that you can get regular updates of whatever videos I am uploading. Thanks a lot.